Okay.
Okay. Hello, everyone. This will be our final project for 311. This is the problem we will be solving. It is a network of nodes as shown on the screen. The goal of this problem is to stimulate a neural network-like structure of nodes that calculate outputs O1 and O2 as shown on the right, based on the binary inputs of I1 and I2. Each node in this network has its output calculated using a specific mathematical formula involving sigmoid functions, thresholds, and biases. So to understand the structure of the network, there are three intermediate nodes, each taking two inputs and two final outputs, and each taking three inputs from the intermediate nodes. So as we can see in the photo here, we have our three intermediate nodes in the middle. Each connection between nodes has a unique threshold and bias, which needs to be randomly generated. Our mathematical formula, each node's output depends on the weighted sum of its inputs, adjusted by thresholds and biases, passed through a sigmoid function. After applying that transformation, the final output is the maximum of zero, and the computed value ensuring non-negative outputs. And these outputs will be displayed in our table. For random initialization, we want to stimulate the variability in a neural network. I plan to initialize the thresholds and biases randomly to all connections. And as we iterate over all input combinations for I1 and I2, since they are binary, there are four possible input combinations. We have the point 00, 01, 10, and 11. And for each combination, we plan to compute the outputs of the intermediate nodes first and use those as inputs to compute the final outputs of output 1 and output 2. As for our results will be shown in a table as shown on this screen, where according to each input, we will provide the output for both solutions. And we will be moving on next to our code explanation of how we solve this problem. For we solve this problem using Python, and we use the library called NumPy. This library is used for numerical operations such as working with arrays, generating random numbers, and performing mathematical computations.
Okay, and then next you see we define our delta function, and this implements the sigmoid function. And our sigmoid function is used to squash the input into a range between 0 and 1. Next, we have our general function that computes the output. And this function will compute the output y of a node as a max between 0 and z, where z is calculated using the given function above. The parameters that we send into the function are the inputs values from xi, the thresholds that were randomly generated, biases which are also randomly generated, and z0 is a constant specific of a node type, and n0 is another constant specific of the node type. And then after that, we initialize the parameters of our intermediate nodes. There are three intermediate nodes, each with two inputs from I1 and I2. Random thresholds and biases are generated for the connections leading into these nodes. The intermediate threshold is a 3 by 2 array of random values between 0 and 1 for the thresholds, and the intermediate biases is also a 3 by 2 array of random integers, either a 0 or 1 for the biases. After that, as you see, we initialize the parameter for output nodes. There are two output nodes, O1 and O2, each with three inputs coming from the intermediate nodes. The random threshold and biases are generated for the connections leading into these nodes. For the final threshold, it's a 2 by 3 array of random values between 0 and 1. And the final bias is also a 2 by 3 array of random integers, either 0 or 1 for the biases. And then as you can see for the constants for Z0 and N0, for the intermediate ones, we use 0.5 because there are two nodes. And then for the final, we use 0.33 because there are three nodes. And the last is when the actual computations take place. For the input combinations, as we stated earlier, there are four combinations of the binary inputs. For the intermediate nodes, each combination of I1 and I2, the outputs of the three intermediate nodes are calculated using our compute output function. Also, for the final outputs, the intermediate outputs, we use those as the inputs to compute the outputs of the final nodes, O1 and O2. And as you see, we set up our output table with the two inputs I1 and the corresponding outputs O1 and O2 are printed in this formatted table, as you see here. And as you see, we ran it and came out. And also, if we run it again, you'll see we'll get different results because of the thresholds and the biases are randomized, so you won't get the same output every time.
Let's do one more. Yeah.
And that concludes our final project. Thank you, everyone, for watching.